This is day 3 of the dilations unit. All right, so far we've learned about dilations, and they increase the length of a segment, and they also create parallel segments, which you saw yesterday. So when we do this, K, remember, is the idea of the scale factor, times a certain segment will give us a new segment. Also, that the two segments will be parallel with one another. And this is the idea that we're going to keep that idea of parallel throughout this unit. So these questions have been broken down for understanding. So our very first thing is, a line whose equation is 3y plus 5x equals 12 is dilated with a center at the origin and by a scale factor of 1/2. What does that mean? It means that the line should get half as long. But if we think about what a line really is, a line, generally when we graph it, will have arrows on both sides, which means that it infinitely goes in both directions. So how could you make something that goes infinitely in both directions half as long? Well, the answer to that is you can't, because it's going to continue whether you make it smaller or not. Okay. So we're going to look at what a dilation would really do to an equation in the next couple questions. Okay, first off, if looking at a linear equation, we can't graph it until it's in y equals form. Okay, so I'm going to take my equation, 3y plus 5x equals 12, and put it into what they had called slope-intercept form. Okay, now remember, slope-intercept form is what you're used to, y equals mx plus b. And they call it that because the m stands for slope and the b stands for y-intercept. Okay, so essentially when they say slope-intercept form, they're talking about getting y by itself. So I'm going to do just that. Okay. I'm going to keep the y on the left-hand side and move everything else over to the right. So I'm going to do that by subtracting 5x. Positive with a negative will cancel. And subtracting 5x on the right. Please don't make the mistake that you cannot really subtract these. 12 minus 5x is not 7x. It is really just these two kept separated. All I need to do is bring down the 3y. Okay, from here, divide by 3. And we really can divide this, so that turns into plus 4. Okay. So now if you remember how to graph without the graphing calculator, the positive 4 represents my start point of 0, 4, because it's the y-intercept. So I'm going to start there. I'm going to plot this on 0, 4. There's my start point. And then the number with the x represents how you're going to move. Now remember, I'm not using the x, I'm just using the number. So negative means to go down. I'm going to go down 5. And it's always, always, always to the right, unless you have to go backwards. So this represents down 5, right 3. So from this point, I'm going to move down 5, right 3. Okay, so I do have a few points. Okay, so I'm just going to take a straight edge, a ruler, whatever you have, to connect these points together. So this is the line that they originally gave us. Y equals negative 5 over 3x plus 4. Okay, now what I'm going to do is I'm going to pick 2 points off of this line to use. I'm going to use the y-intercept, and I'm going to use the third point that I plotted. Okay, those 2 points are 0, 4, and 6, negative 6. Now from yesterday's lesson, we learned that when we have a scale factor of 1/2, I multiply both the x and the y by this half. Okay. So I'm going to do that. The 0, 4 would be 0 times 1/2, which is 0. And this would be 4 times 1/2, which is 2. That'd be one of my new points. Now I need a second point in order to connect to make a line. Half of 6 would be 3, and half of negative 6 is negative 3. Okay. So I'm going to plot those. So graph the new points. So when they talk about new points, these are your new points. Okay, 0, 2, and 3, negative 3. There they are. Okay. Now I'm going to connect them making a line. Okay, so I graphed them on the grid above, and now I need to be able to state the equation of the new lined form. Well, if I look, we can clearly see that these two lines are parallel, but I can also prove it. From this point to this point here, it went down 1, 2, 3, 4, 5, and right 1, 2, 3. So therefore the slope is negative 5 over 3x. And if I look, I can see the y-intercept right here. So the y-intercept is a positive 2. Now we're going to make that connection piece. What does a dilation do to an equation of a line? Well, if we look, this number, the y-intercept, is the only number that changed about this equation. The slope did not. So as we've seen before in the previous lessons, that when we dilate an image, it preserves the parallel. Okay, so back up here, sorry, A prime, B prime. We talked about parallel in the previous lessons. It keeps the lines parallel, or segments. So from here, the only thing that changes about this, how did the line change? The y-intercept changed. Okay. And it changed by specifically the y-intercept is being multiplied by the scale factor. So 4 times 1/2 gives me 2. But notice the slopes did not change. Okay, so something new that we're learning today is that of an equation of a line, it only affects the y-intercept. So it looks like it's going to move the line up or down depending on the scale factor. Okay, flip over to the next page. Okay. Now we're going to look at a line here, y equals 3x. But if you notice something is missing, it's actually missing the y-intercept. So what we need to understand is when there is no y-intercept attached to the number, that's because it's 0. And we never just write plus 0. And we just leave it as 3x. Okay. So if I graph this line, you'll see the start point here of 0 is really 0, 0. So I plot that number, 0, 0. The number in front of the x is the slope, and yes, it's going to tell me how to move, which in this case is going to be up 3, but right 1. Even though it doesn't have it as a fraction, we put it over 1 to make it a fraction. So I'm going to move up 3, right 1, up 3, right 1, to get my points. Okay, so I'm going to graph it, which means I'm going to actually connect it and make it into a line. Don't forget arrows and labels. Y equals 3x. Okay, now I'm going to pick any 2 points off the line as it says. State 2 points that are on the line. Okay. 0, 0 is one of them. And 1, 3 is another one. Now it says to perform the dilation with a scale factor of 2. So remember, scale factor of 2 means to take those coordinates and multiply by 2. So 2 times 0 is 0. And 2 times 0 is also 0. Okay. The second one. 2 times 1 is 2. 2 times 3 is 6. So these are my 2 new points. These are the new points that I'm going to plot on the grid provided. I'm going to do those ones in purple, so that way they stand out a little bit. Okay, well, there's 0, 0. And here's 2, 6. Well, if I connect those 2 points, I end up with the same line again. Okay, so when it asks me for a new equation, there isn't one. It's the same exact one. Now the question is, why didn't it move this? Why didn't it move it up or down? Well, that's because of the y-intercept. Now remember, we just talked about that the only thing a dilation will affect is the y-intercept. And here, it's 0. Well, if you multiply 0 by a number, you're still going to get 0. It doesn't change it. So the dilation is not going to change its equation, and that's because 2 times 0, 0. Now remember, this 0, 0 is the y-intercept, equals 0, 0 still. So it's not moving up or down at all. It can't move at all because I don't have any numbers to multiply by. Okay? So that's the one case where it can't affect the y-intercept because the number is 0. All right, moving down to what's supposed to be exercise number 3. All right, if the line y minus 7 equals 3 parentheses x plus 5 is dilated at the center, at the origin, and a scale factor of 4. Okay, scale factor of 4. Which of the following equations best describes its image? Well, let's take a look at that. Okay. Now, if you notice, this is not in y equals mx plus b form. Okay. This is in something called point slope form. What does that mean? That these two numbers here represent a point, and this number right here represents the slope. Okay, so point slope form formula is y minus y1 equals m of x minus x1. Okay. So this should be pretty easy. The slope is 3. It's not going to change. So it's 3. Now remember, if I dilate it, a dilation only affects the point. And whether that point is the y-intercept or a point on the line itself, it doesn't make a difference. And the slope will stay the same. So if I'm looking at this, all of these numbers here represent your slope. And looking at them, if slope needs to stay the same, I'm going to get rid of choice 1 and 3. Why? Because I need the slope to be 3 as the previous one is. Okay. Now as for the point is the number that's going to be multiplied by the scale factor. So if you remember, x goes with the x, y goes with the y. So the x is the number on the right. Now remember, since the formula has a minus sign in it, the only way to get this to turn to a positive is if I had minus a negative. So this 5 must have been a negative at some point. And this is minus the y. Well, since it didn't change the sign, I'm going to keep that sign right there, 7. Okay. So I do nothing more than multiplying both the x and the y by the scale factor of 4. So if I take that and multiply it by 4, both of them, the new number comes out to be negative 20, 28. Well, if we look, there's only one of them that makes sense, and that's choice 2. That concludes the lesson for today. If you have any questions, please see me in class.